Hello, today's lesson is going to be 2.4b, the second part of our two-part lesson on multiplying and dividing with scientific notation today. So again, our standards are going to still come from EE4. We're going to be able to perform operations with numbers expressed in scientific notation, and these today will be multiplying and dividing. So there is your standards. I can multiply numbers with written in scientific notation, and I can divide numbers written in scientific notation. So I'm going to minimize myself. Let's get going. Here's my math meme of the day. And moving on. Hopefully that gave you a chuckle. Gave me a chuckle. Good news with multiplying and dividing with scientific notation. Remember how adding and subtracting, we needed to have the same power of 10 before we could add or subtract the multipliers? Well, we do not have to do that with multiplying and dividing. It's way easier than adding and subtracting with scientific notation. At least I think it is. Why is it easier? Because you can use powers of exponents to solve the problems. That was back in our first lesson when we talked about the rules for exponents. So dividing scientific numbers, we'll start with dividing. When the sun makes an orbit around the center of the Milky Way, it travels at, let me just get my little annotation here. You can underline it. It travels at 2.025 times 10 to the 14 kilometers. The orbit takes 225 million years. Wow. At what rate does the sun travel? Write your answer in scientific notation. This is called a dirt problem, and I'll bring it up in a minute, but it's D, dirt, so to speak, equals RT. What do I mean by that? Distance equals rate times time. Okay? We are looking for R, the rate. We are given the distance, we are given the time. The time is 225 million. The distance is here. We are solving for R. So let's take a look at how that's going to work. We're going to use the dirt equation. D equals RT. D stands for distance, R stands for rate, and T stands for time. This equation can be manipulated to solve for whichever part is missing using algebra or the triangle. So if I were using algebra, I would get R by itself because I'm solving for rate. To get R by itself, I would divide both sides by T. And then my T's on this side would cross off. And R would equal D, distance, divided by T, time. So that's how you do it algebraically to manipulate to get R. So we are going to be doing a division problem because we are given distance and we are given time. However, you can, if you don't want to use algebra, you can use the fun triangle. And in the triangle, so we're looking for rate. So what I would do then is I would cover up rate, and there's my formula to find it. Distance divided by, there's that black bar again, distance divided by time, D over T. So that's another way of doing it if you prefer to use the triangle instead of algebra. Okay, so now we know it's a division problem. So yeah, we cover up the part we're missing, and in this case it's an R. Sometimes it could be a D or a T, right? And you have the equation to solve the missing part. So here's the problem again. We're going to use our dirt equation. We're going to use our triangle if necessary. We're going to figure out if you are solving for D, R, or T. We figured out we're solving for R. We cover up the R. It's distance divided by time. Okay, D over T. So let's do that. We're going to plug in your numbers given in the problem. So we're going to put D on top, and we're going to put T on the bottom. D divided by T. 2.025 times 10 to the 14 divided by 225 million. So there it is. Put 225, 2.025 times 10 to the 14. That's your distance. That's your D. Your T is 225 million years. So there's your distance and your time. However, We are not in the right format yet to be able to do this. So we have to bring it back. Step 3, change all numbers into scientific notation. Which one do we have to change? Well, the bottom, right? That's not in scientific notation. We have to get a number between 1 and 9.99. So this is really 225, and then it's million, right? So that's going to be 1, 2, 3, 1, 2, 3, right? Tens, hundreds, thousands, 10,000s, 100,000s, millions. Oh, no, that is millions. Tens, 100,000s, 10,000s, 100,000s, millions. 225 million. No, that's 225 million. Okay, so anyways, we're going to move our decimal, and we're going to get 2.25 times 10 to the 8th. Why? We're going to move it. Now my black bar showed up again, so I don't know if I can do this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and let's clear it because we got it there for us. 2.25 times 10 to the 8th. Now they're both in scientific notation. Remember what I said with multiplying and dividing, you do not have to have the same power of 10. This 14 and this 8 do not have to be the same power of 10, which is nice because then you don't have to move decimals that way. So now let's see the next step. Divide the multipliers, the numbers in front of the power of 10. We are going to divide 2.25 by 2.025 by 2.25. Top number on the inside, bottom number on the outside. So let's do our division. So we have to move our decimal 2 places to the right because if there's a decimal on the outside number, we have to get rid of it. We move it 2 to the right. So now we move this one 2 to the right. There's our new decimal spot. We're going to put it up there right away, and then we're going to start dividing. 225 is now our number, and we can't divide it into 2. We can't divide it into 20. We can't even divide it into 202, so we have to divide it into the whole 2025. So 225, so that's approximately 200, 2, 4, 6, 8, 10. It's approximately 10, so we'll say 9 because it's 225. Let's see what we're at when we do this. 5 times 9 is 45. Put down the 5, carry the 4. 2 times 9 is 18, plus 4, 22. Carry the 2. 2 times 9 is 18, 19, 20. That's exactly correct. So it goes in there 9 times. And the 9 is going to go over my 5 because I took it into the whole number. Okay, and I'm sure the computer is going to bring that up now. Should bring it up. Step 5, divide the powers of 10 using the exponent. Let's put our 0.9 in there. There's our 0.9. Okay, that was what we just figured out. And now we have to do the powers of 10. We have a 10 to the 14, and what was the other one? 10 to the 8th. Yeah, so we have the 10 to the 14 for the distance, and the time was 10 to the 8th. So how do we divide with powers that have the same base? What was the rule, the exponent rule for that? When you're dividing exponents with the same base, you subtract the exponents. So it's 10 to the 14 minus 8, 10 to the 6th power. So our final answer then will be 0.9 times 10 to the 6th power. I'm just seeing. Oh, combine the answers. We just did that. Did that verbally. We didn't actually officially do it. So 0.9 times 10 to the 6th. Oh, what is one more step we need to do, right? We have to change into the correct scientific notation because 0.9 here is not between 1 and 9.99. I have to move my decimal 1 to the right. When I move my decimal to the right, I decrease my power of 10. So 6 becomes a 5. So now 9 times 10 to the 5th is in scientific notation. I don't know if the answer is going to come up big and green. Oh, notice that we had to move the decimal to get a number between 1 and 9.99 and decrease the power of 10. We did that. Just talked about that. Okay, it's your turn to try a division problem. See you back in a moment. Welcome back. Let's continue. This time we're going to talk about multiplying with scientific numbers. Okay, light travels at a speed of 1.86 times 10 to the 5th miles per second. It takes light from the sun about 4.8 times 10 to the 3 seconds to reach Saturn. Find the approximate distance from the sun to Saturn. Hint, hint, this time we're looking for distance. This is going to be a dirt equation, right? So which one is, so if we're missing distance, D equals RT is our standard formula that we can manipulate. We are probably being given R and T, right? So which one is R, which one's the rate, and which one's the time? Well, speed is another word for rate. This is your rate, and it takes from the sun about 4.8 10 to 10 to the 3rd seconds. Seconds sounds like a time to me, so that's your T, okay? Using the dirt equation, D equals R times T. The equation can be manipulated to solve for whichever part is missing. We don't have to manipulate it, we're looking for distance. There's our triangle. We could also see how it works with this. If we were to cover up what we're missing D, that's what we're looking for. The formula at the bottom is R times T. So that's how we use our triangle. Covered up D, we found that this formula was R times T. Okay, continuing on. Step 1, figure out if you're solving. We did that already. We're solving for distance. Okay. Step 2, we're going to plug in our numbers given in the problem. So we are given T, 4.8 times 10 to the 3rd seconds, and rate, speed of 1.86 times 10 to the 5th. We're going to multiply those together. We're going to multiply 1.86 times 10 to the 5th by 4.8 times 10 to the 3rd. So good news, we don't have to have the same power of 10 when we're dividing or multiplying. We don't have to have the same power of 10 before we can do anything. So what do you think the next step is going to be in our problem? Well, we're going to what? Multiply the multipliers, right? That's the next step. Bring it up. Change all numbers into scientific notation. Well, they already are. So we have nothing to change this time like we did in the division problem. So we're just going to multiply the multipliers together. I guess I have to do that on the next screen here. 1.86 times 10 to the 5th, 4.8 times 10 to the 3rd. We are going to be multiplying 1.86 times 4.8. When we're multiplying, we do not have to line up our decimal points like we do with adding and subtraction. We just pretend they're not there until the end of the problem. So 6 times 8 is 48. Put down the 8, carry the 4. 8 times 8 is 64 plus 4 is 68. Carry the 6. 8 times 1 is 8 plus 6, 14. 4 times 6 is 24. Put down the 4, carry the 2. Cross off the other one that was there from the previous one. 4 times 8 is 32 plus 2, 34. Put down the 4, carry the 3. 4 times 1 is 4, plus 3 is 7. And then I add the two numbers together. I'm going to run out of space almost. I think I'll make it 8. 8 plus 4 is 12. Carry the 1. 9. 7 plus 1 is 8. Okay, and now I put my decimal. I have two numbers here after the decimal, and I have one number here after the decimal. So, did I do 14.8? Should be 4.8, right? I don't know why this is here. Oh, because I was adding. Okay, so now we have three numbers after the decimal. 1, 2, 3. So that's 8.928. So that should pop up on the computer here. .928. So there it is. Just wanted to remind you how to multiply with decimals. So now we have to do the powers of 10. Multiply the powers of 10 using exponent rules. We have our multiplier, 8.928, times, what do? We have to multiply 10 to the 5th times 10 to the 3rd. When you're multiplying numbers with the same base, you add the exponents. So it's 10 to the 5 plus 3, or 10 to the 8th. So 8.928 times 10 to the 8th. We only have to change it if we are not in scientific notation. So let's go to the last step. Combine the answers and change into correct scientific notation if necessary. We are already in scientific notation because 8.928 is between 1 and 9.99. So we are in scientific notation. No need to change any numbers. Okay, it looks like it's your turn. Give it a try. Welcome back. Okay, let's do a little focus on higher order thinking. How is multiplying and dividing numbers in scientific notation different from adding and subtracting numbers in scientific notation? Can you give me one way that they are different? Well, what did we say about adding and subtracting? You have to have the same powers of 10, but you don't for multiplying and dividing. So here is a chart comparing. So in adding and subtracting, the powers of 10 must be the same in order to add or subtract the numbers. In multiplying and dividing, the powers of 10 do not have to be the same to multiply or divide the numbers. Adding and subtracting, after adjusting the powers of 10 to be the same, the multipliers are added or subtracted. In multiplying or dividing, no need to adjust the powers of 10. The multipliers are divided or multiplied. Number 3 here, there is no need for the rules of exponents because the powers of 10 must be the same before we add and subtract. Multiplying and dividing, the rules of exponents can be used to figure out the powers of 10. And finally, under adding and subtracting, in the final answer, the decimal point and power of 10 may need to be adjusted so it is in scientific notation with a number between 1 and 9.99. For multiplying and dividing, in the final answer, the decimal point and power of 10 may need to be adjusted as well so that the answer is in scientific notation. If you'd like to screenshot this page, it's a good comparison. Go ahead, pause the video and screenshot it. Okay, moving on. We're still focusing on higher order thinking. A student found the product of 8.10 to the 6th times, and 5 times 10 to the 9th, so they multiplied them together, to be 4 times 10 to the 15th. So what is the error? What did they do wrong? Well, we're going to multiply, right? So we're multiplying the 8 times the 5. That's going to give us 40. And I'm sure the computer is going to show this to us, but let's do it like this. And then we have to take the exponent part, 10 to the 6th and 10 to the 9th. What do we do with that? We add them, right? So 40 times 10 to the 6 plus 9, 15th. Right? But this is not in scientific notation because 40 is bigger than 9.99. So I have to move my decimal 1 to the left and get 4.0, or just 4, right? Times 10 to the, when I'm moving my decimal to the left, what am I doing? I am increasing my power of 10, right? So it should be 4 times 10 to the 16th. The student got 4 times 10 to the 15th. What was their error? They forgot to increase the power of 10. So let's see that on the computer. Multiplied the multipliers, use exponent rules to find the power of 10, 10 to the 15th. Combine the multiplier and power of 10 and adjust if necessary into scientific notation. So we had to change it to 4.0 times 10 to the 16. The student's error was that when she adjusted the number in her answer into scientific notation, she moved her decimal point correctly, but she forgot to adjust the power up from 15 to 16. I did say 16, didn't I, when I did that? I hope so. Okay, next. Solve the following. Ooh, look at this. Lovely problem. 4.87 times 10 to the 12th minus 7 times 10 to the 10th divided by 3 times 10 to the 7th plus 6.1 times 10 to the 8th. How do we solve this? Well, one step at a time. It's not as bad as it looks. We're going to rewrite the top to get the same powers of 10 because we're going to be subtracting, so we need the 12 and the 10 to be the same number, correct? Yes, subtraction, they have to have the same number. I want to clear my, there we go. So 4.87 times 10 to the 12th will be rewritten as 487 times 10 to the 10th. This time I actually went down instead of up. I could have increased this to the 12th power. This time I showed you the other way now, moving the decimal 2 to the right, decreasing the power by 2. So now I have 487 times 10 to the 10th. Now I can subtract the multipliers on the top, 4.87 and 487. So 487 minus 7 will give me 480 times 10 to the 10th power. So far, so good. All I did was the top. I adjust my answer to be in the correct scientific notation because 480 is well above 9.99. I have to move my decimal 2 to the left to get 4.8 times 10 to the 12th. I increased my power by 2 because I moved 2 to the left. That's my top number now. I've solved the top part. Keep going on. I rewrote my top number as 4.8 times 10 to the 12th because we solved that. Now we're going to solve the bottom. It's an addition problem, so we know we have to have the same powers of 10. So let's get the same powers of 10. I'm going to rewrite 6.1 times 10 to the 8th. I'm going to go down. So I'm going to move my decimal 1 to the right, and I'm going to decrease my power to 10 to the 7. So I'm doing this one the opposite way I showed you in the other ones, just to show you how it's done. So now I have 61 times 10 to the 7th. Okay. I'm going to add the bottom multipliers. I'm going to add 61 plus 3. And I'm going to get 64 times 10 to the 7th. But that's not in scientific notation, so I have to adjust 64 times 10 to the 7th to get it in the correct scientific notation, which would be 6.4. And since I moved my decimal 1 to the left, I increased my power to 10 to the 8th. So the bottom number is going to be 6.4 times 10 to the 8th. Okay, that's my bottom number. I'm not finished, but I'm almost finished. Gives me the answer already because I forgot to put that as an animation. So here is my bottom number, 6.4 times 10 to the 8th. Here was my top number. Now I'm going to divide them. I'm going to divide the multipliers, 4.8 divided by 6.4. If I do that, I'm going to get 0.75. I'm going to use my exponent rules for dividing 10 to the 12th by 10 to the 8th, and I'm going to get 10 to the 12 minus 8, 10 to the 4th. I'm going to combine my multiplier and my power of 10, 0.75 times 10 to the 4th, and then there's the answer at the bottom. I have to adjust my answer in correct scientific notation. 0.75 is below 1, so I have to move my decimal 1 to the right. And if I move it 1 to the right, I decrease my power of 10 to 10 to the 3rd. So it's 7.5 times 10 to the 3rd. Wow, that is the answer. Seems like a lot of work, but I'm going to give you a chance to do an extra credit problem like that worth 10 extra points on your video assignment. So if you'd like to tackle that kind of problem, I would love to have you try it. And it's worth 10 points, so it's definitely worth trying. Okay, it's your turn to try a couple of these focus on higher order thinking problems. See you back in a moment. Okay, I'm gonna play my video here. I don't know if I played this in a previous video or not, so I wanted to play this.
Some numbers are really big, some numbers are really small. I wish there was a way to easily express them all. found there's an easy way to show extreme scientific play. Scientific notation does it easily. And now I love science more than I ever did before, can't you see? Express your number so that it's more than 1, but less than 10. Take that number and multiply it by 10 to the proper exponent. 300 in scientific notation is 3 times 10 to the power of 2. 10 to the power of 2 is 100 times 3, that's 300, so there's your proof. Scientific notation uses exponents, go with the base of 10, so you don't have to write out so many zeros again. And again, and again. Take a number like 0.0023, plug it into 8 times 10 raised to the power of b, where a equals 2.3 and b is -3. You get 2.3 times 10 raised to the power of -3. Express your number so that it's more than 1, but less than 10. Take that number and multiply it by 10 to the proper exponent. 0.03 in scientific notation is 3 times 10 to the -2. 10 to the -2 is 0.01 times 3, that's 0.03, so yeah, there's your proof. Express your number so that it's more than 1, but less than 10. Take that number and multiply it by 10 to the proper exponent. When you use scientific notation, you become a real hero. It's 5.2, it's not a trick, it's 5.2 times 10 to the power of 0.
All right. There we go. And I'm back. And I think we're at the end of our lesson. Oh, here's your extra credit problem I told you about. It's going to be worth 10 extra credit points on your video score. So you want to get a piece of paper and write down this problem, and then you want to give it a try for those 10 extra credit points. That's a lot of extra credit points. So I'm going to take 3.92 times 10 to the 9th minus 4 times 10 to the 6th on the top, divided by 4 times 10 to the 6th plus 8.2 times 10 to the 7th. So pause the video, write it down. Okay, we are now, are you up for the challenge? Okay, don't forget to write down the problem before the video ends. And then on Google Classroom, you will have your assignment, and that is the end of the lesson. So I will see you next time. Bye.